All right, so these are for your notes for in class. It's really important that you remember how to do these problems, specifically because they relate to how we're going to get you ready for Algebra 2. So this is a substitution problem, and it says substitution, but there's lots of ways you could solve it, but we're promoting substitution. And in order to do that, I need to be able to replace things. And right now there's nothing to replace, but I see there's this y there, and I want to get it out. So I'm going to actually rewrite this problem, so 12x plus y equals 21, and we're going to solve for y by subtracting 12x from both sides. So y is equal to negative 12x and then plus 21. So now we can replace the y value, we can replace y with negative 12x plus 21, and that's because y is equal to negative 12x plus 21. So now, when I see this y here, I can actually go and replace it with that negative 12x plus 21. So let's rewrite this second equation and replace the y when it's time. So 18x minus 3y, but remember y is going to be all that stuff, equals negative 36. What is y? So we're replacing the y value here with the stuff that y equals. Y is negative 12x plus 21. Well, now it's a game of distribution and solving. We've got to distribute that negative 3, so we get 18x. Negative 3 times negative 12x is positive 36x, and negative 3 times positive 21 is negative 63. And then the rest just comes along for the ride, so equals negative 36. Now I see that I've got some like terms there. So 18 plus 36 is 54x minus 63. So right now we're just solving for x. I'll add 63 to both sides, so add 63. We get 54x equals 27, okay? And then divide by 54. So this is all solving. So then we get x equals a half, or we know that to be 0.5. So x now is 0.5. That's a good thing because now I can replace x with 0.5. So in the equation up here, we're going to copy this down. We're going to copy this down because we know that y equals negative 12 times whatever x is plus 21. And x we now know is 0.5. So negative 12 times 0.5 plus 21, I'm using a calculator, y is going to equal 15. And we always write our answer as an ordered pair. So our ordered pair answer is 0.5, comma, 15. And those are the x value and the y value. So we can do it with this problem as well. Go ahead and pause the video and try setting it up yourself. All right, hopefully you've set it up yourself by now. 32x plus 21 times whatever y is equals 29 because we're replacing y with 4x. So every time I see a y, I'm going to replace it with 4x. Now, this is a little bit more simple because it's one quick substitution. So we get 32x, oh, I should use a different color for that, 32x plus 84x equals 29. 32 plus 84 is 116x equals 29, so divide by 116. X equals 1/4 or 0.25. And now that we know an x, we can actually use this because y is equal to 4 times whatever x is. And we know x is 0.25, so y equals 1. And our answer comes as an ordered pair, so our answer comes as an ordered pair of x comma y. So x is 0.25, comma 1. So this is our answer. This is our answer. Now I want you to try setting this up. Please pause the video and try setting this up yourself. We're not going to actually solve this, but please do try and set it up. Okay, so there's actually two ways to solve this. In version 1, we would just substitute x, and I'll use a color for that, substitute x with y plus 1. So in the second equation, instead of negative 2x plus 3y equals 2, the x is y plus 1. And in version 2 of this thing, so the second version, you probably want to rewrite this, so y plus 1 equals x, solve for y equals x minus 1, and you're going to replace the y value, in this second equation with x plus 1, or x minus 1, so negative 2, I'll use the right color, so negative 2x plus 3y equals 2, and we're replacing y with x minus 1, because that's what y equals up there. And then you could, no matter how you solve it, right, like if you finish solving it, you'll get the correct answer. So I'll just fast forward through that. Make sure that you write down the steps. All right, now that we know what a system of equations is, and a system of equations is where the points intersect, we're going to think about writing a system of inequalities for this. So the first step here is to write the system. And I'm going to do the red in the red color. And I notice that each tick mark is actually going up by 2. So this is 2, 4, 6, 8 to make that 10. And again, 2, 4, 6, 8. 10. So just keep that in mind. So in this red equation, my y-intercept is 4, so I'm going to say y-intercept is 4, and the slope appears to be going down 4 and over 2. So down 4, so negative 4, and over 2. So that's my slope, and it appears that in this graph, if I'm graphing the red line, the shaded region is less than. So the y values are all less than or equal to, and we use the equal to sign because it's a solid line. Now we're going to kind of repeat that process, so it looks like my slope is negative, or my y-intercept is negative 3, so negative 3 is the y-intercept, and it appears to be going up 3 and over 3, and 3 over 3 is 1, so we could say just 1x, or 3 over 3x, and then it appears that we're shading above the blue line. So we're going to shade above, and because it's a dashed line, there's no equal sign. So y is greater than 3 over 3x minus 3. Now, you might have simplified these just a little bit. So what I want to be really clear is if you were to choose a point from each region, it would only work in that respective region. So if I picked a point up here, it would only work in the blue equation because it's only shaded by blue. If I picked a point right here, it's only shaded by red, so it only is going to, if I pick that point and plug it in, it's only going to work in the red equation. The only space, the solution area, is where it's shaded by both. So this purple area is where it's shaded by both. And I'll show you that when I substitute a point, like my favorite point 0, 0, when I substitute 0, 0 in, is this a true statement for the red or the blue? Is 0 less than or equal to 4? Because that's 0. 0 plus 4? Yeah, that's a true statement, right? That's a good thing. That's a true statement once we plug in 0. And again, 0 is also greater than 0 minus 3. Yeah, 0 is definitely bigger than negative 3. Great, excellent. So this point actually satisfies both equations. And you can test other points as well, but for now, we'll just test one. All right, so real quickly, I want you to think, which represents the solution based on this picture? And then if we were in class, you'd write this in the chat. So which region represents the solution to this system of inequalities? Remember, the system of inequalities is where it's shaded by both. So hopefully you picked C, purple, the purple region. Yeah, that is the only system solution here because it's the only place that's shaded by both. Let's take a quick look. We just really practicing this concept of which system is represented by which. And so I hope that you see that everything less than 3 is everything that's related to this blue line, right? This blue line lives at positive 3. So everything less than that. So this x is less than 3 is going to be the blue shaded stuff, which obviously means red shaded stuff. And it also, we can note, the type of line. This is a dashed line because there is no equal sign, and this is an equal sign, so it's a solid line. So just keep that in mind. Thanks for taking notes. Please make sure that you submit these at the end of class.